Right, welcome to another Learning Masters video. Um, in this video, we'll be looking at solving an equation via substitution. So we're looking at solving an equation via substitution, and we're going to use an example from an older Cambridge exam. So it says, by using a suitable substitution, solve the equation. And this is the equation that we have. All right, so to make the substitution, you must first identify what you're going to substitute. What really makes this equation challenging is this 2x minus 3 squared, right? For this factor. I just want to highlight it for you that this is what is making this equation difficult. So that is exactly what we are going to substitute. So let's make the substitution. All right. So we're going to say, for example, let u equals, or let 2x minus 3 squared, the whole thing including the square. Why am I including the square? It's because both of these have the square. So I'm not going to just say 2x minus 3. I'm just going to say 2x minus 3 squared. So if I'm calling this u, then I get this equation. So the equation now looks like this. U minus 4 over u minus 3 equals 0. Now I can then solve this equation. I'm going to use a little bit, okay, let me just work here. So to solve this equation, you could add 3 to both sides, or you can say take the 3 to the other side. So add 3 to both sides, or take this negative 3 to the other side. Then you want to get rid of this u in the denominator. So what you're going to do, you're going to then multiply by u on both sides. Why would I do that? Because if I multiply it by u, it's going to cancel this u in the denominator, but you're actually multiplying by u on both sides. So that means in this side, I'm multiplying both terms by u. U times u is u squared. U times minus 4 over u. Well, the whole point was to get rid of the u in the denominator. The u's will then cancel out. When you say u times minus 4 over u, the u's cancel out because it becomes minus 4u over u. Then the u's cancel out, and then we're left with this. 3 times u is 3u. This looks quadratic, so I'm going to put it in a standard quadratic form by saying u squared minus 3u. So I've actually brought the 3 to this side again, or subtracted 3 again. So it's u squared minus 3u minus 4 equals 0. Okay, the factors of this quadratic equation is going to be u. Then factors of 4 that can give me 3. Well, it's going to be 4 and 1. The constant is negative, so that means signs are different. That's minus 4 over there. And then that's going to be plus over there. Okay, so those are the two factors. Now, okay, now we can solve this equation. This equation then gives us a solution u equals 4 or u equals minus 1. Now, what I can do here is what I call back substitution. Back substitute means what is originally used or is used to get u, or what I originally substituted u for in the original equation, I put it back. So I'm just going to write it up here at the top because it doesn't look like I have a lot of space. So I'm going to do that on this side. So u is 2. Give it a minute. Okay. Just a little bit of a technical glitch. Should be fine now. Okay. Remember, let me just pull it up here. U is 2x minus 3 squared. So I've got two options. Let me do the one option this side. So u squared, so u equals 4. I'll do this side. That means 2x minus 3 squared is equal to 4. Right, now I need to solve this. To solve this for x now, I need to do inverse operations. I need to get rid of the square. To get rid of the square, you need to square root. But whatever you do on one side, you do on the other. Then this is going to give me 2x minus 3 because the square roots cancels the square. Now, the square root of 4 is not just 2. It's plus and minus 2, because positive 2 squared is 4, minus 2 squared is 4 as well. So that means this gives you two solutions. 2x minus 3 equals 2. That's a positive 2 case. Or 2x minus 3 equals a negative 2. And then I solve this by adding 3 to both sides, or taking the 3 to the other side. So it's going to be 2 plus 3. Then 2x is equal to 5. Divide by 2 both sides then. Then I get the final answer as x equals 5 over 2. Right, so that's the one side. Now if I do this side, the same thing, 2x, I took the 3 minus 3 over. It's going to be minus 2 plus 3. Then I have 2x is equal to 3 minus 2. That's 1. You divide by 2 both sides. Then x is equal to a half. So those are my already two solutions for x. That's coming from the case where u was equal to 4. Now you mustn't forget that there's another case where u is equal to minus 1. So let's do that this side. U is equal to minus 1. Then what's going to happen then with that, u equals minus 1. I'm going to back substitute again. 2x minus 3 squared is equal to minus 1. Again, what you would want to do is then square root both sides. But now you're square rooting a negative. What you should now remember is that the square root of a negative number gives you an imaginary answer, or non-real. In fact, square root of minus 1 in math is usually just called I, because that's standard imaginary number. Okay, so this then just gives you that 2x minus 3 is equal to I. But most of the time we don't deal with the complex case or imaginary number. So most of the time, for most people, you would do this and you would say something like 2x minus 3 cannot equal to minus 1, because u, remember, is 2x minus 3 squared, and it cannot equal to minus 1 because it leads to an imaginary number. All right, I hope this video was helpful for you. I hope it is great in learning how to solve an equation by substitution. Please contact us at Learning Masters for more math tutoring. We do English tutoring, math tutoring, science tutoring. We do variety of curricular CAPS, IAB, Cambridge, IGCSE, A-levels, GCSEs. We do IB. We do university first and second year. We do physics, chemistry, natural sciences. We do grade 8 to 12. We actually do maths all the way from grade 4 to 12. So if you want to reach us, you can reach us on this number, 071 400 9965. And this is for WhatsApp and call, 071 400 9965. All right, thank you so much. I hope this video, you found it insightful. Have a great, great day further.